The 19th century was a time of incredible change. We went from horse-drawn carriages to trains that crossed continents. Factories sprang up, producing goods at rates never seen before. The driving force behind this revolution, steam engines. These powerful machines harnessed the energy of steam to drive everything from locomotives to factory machinery. Before steam engines, factories relied on water wheels. These were limited by location and inconsistent water flow. Steam engines, however, could be built anywhere and provided reliable power. This led to the growth of factories and cities, changing the way people lived and worked. The impact of steam engines went far beyond factories. Steam-powered ships revolutionized sea travel, making it faster and more efficient. Trade routes expanded, connecting distant corners of the globe. The world was shrinking, all thanks to the power of steam. Building a steam engine was no small feat. It required careful planning and skilled craftsmanship. The first step was designing the engine. Engineers would create detailed blueprints outlining every component and its dimensions. This was crucial for ensuring that all the parts would fit together perfectly. Choosing the right materials was just as important as the design itself. Cast iron, with its strength and ability to be molded into complex shapes, was the primary material for engine blocks, cylinders, and other large components. Steel, being even stronger, was used for parts that experienced high stress, such as pistons and connecting rods. The design phase also involved calculating the engine's power output, fuel efficiency, and operating pressure. Engineers had to consider factors like the intended use of the engine, the availability of fuel, and the environment in which it would operate. A steam engine designed for a locomotive would have different requirements than one intended for a factory. With the blueprints finalized, it was time to start making the engine's components. One of the most important processes was casting. This involved pouring molten metal into molds, allowing it to cool and solidify, and then breaking away the mold to reveal the finished part. Skilled foundry workers were essential for creating high-quality castings. They had to carefully prepare the molds, ensuring they were free of defects. The temperature of the molten metal had to be just right to ensure proper flow and cooling. The largest and most complex casting was the engine block. This massive piece housed the cylinders and formed the backbone of the engine. Other components made through casting included the cylinder heads, pistons, flywheels, and various valves and fittings. Each casting was carefully inspected for flaws before moving on to the next stage of production. Section 4. Shaping metal with precision, machining the engine's heart. While casting produced the rough shapes of the engine's components, machining was needed to achieve the required precision. This involved using various cutting tools to shape and smooth the metal surfaces. Lathes, milling machines, and drilling machines were common sights in 19th century machine shops. Skilled machinists were highly valued for their ability to operate these machines with accuracy. They followed the blueprints meticulously, removing just the right amount of metal to achieve the desired dimensions and tolerances. A slight error in machining could render a component useless, potentially causing the entire engine to malfunction. The cylinders in particular required a high level of precision. These cylindrical chambers housed the pistons, and any imperfections could lead to steam leaks, reducing the engine's power and efficiency. The smooth, precise movement of the piston within the cylinder was crucial for the engine's operation. Section 5, the boiler, where fire meets water to create power. No steam engine would be complete without a boiler. This is where the magic happened, the transformation of water into steam, the lifeblood of the engine. Boilers were typically large, cylindrical vessels made from steel plates, riveted together. Inside the boiler, a fire burned fiercely in a firebox, heating the water surrounding it. The water, contained within a network of tubes or a single large drum, transformed into steam under intense heat and pressure. The hotter the fire and the higher the pressure, the more powerful the steam produced. Building a safe and efficient boiler was a complex task. The choice of materials, the thickness of the steel plates, and the design of the firebox and tubes all played crucial roles in determining the boiler's performance and lifespan. Section 6. Valves and linkages controlling the flow of steam. Creating steam was only half the battle. To harness its power, engineers devised ingenious systems of valves and linkages. These mechanisms controlled the flow of steam into and out of the cylinders, dictating the engine's speed and direction. Imagine the valve gear as the brain of the steam engine. It received instructions from the operator, usually through a lever or throttle, and translated them into precise movements of the valves. These valves, often made from brass or bronze for their heat resistance, opened and closed at just the right moments, allowing steam to enter and exit the cylinders, pushing the pistons back and forth. The linkages, a system of rods and levers, connected the valves to the piston rod. As the piston moved, it drove the linkages, which in turn controlled the timing of the valves. This intricate dance of steam, pistons, valves, and linkages was what brought the steam engine to life. Section 7. A symphony of iron, assembling the steam engine. With all the individual components meticulously crafted, it was time for the final act assembly. This was a massive undertaking, often requiring teams of skilled workers toiling away in cavernous workshops. Cranes and block and tackle systems were employed to lift and position the heavy components.